Hi everybody, happy Valentine's Day. Sorry I couldn't be at school. We're going to do a video here for the notes. You should have gotten a new packet from your sub with a green cover on it. This should be the very first page that's in there. What we're going to do in this next unit is transformations of the graphs that we worked on in the last unit. So if you can take a look at the screen here, I've got pictures of sine of x and cosine of x. And just to refresh your memory, the amplitude of both of them is 1. The sinusoidal axis, or the line that goes down the middle that they're rotating above and below, is at y equals 0. The period of the graph is either 360 or 2 pi, depending on what mode you are in. So another thing that I want to draw your attention to that's going to be important here is the difference between sine and cosine. They're clearly the same shape. We're going to be graphing both. But I want you to take note of how the sine graph typically starts on the sinusoidal axis. You see where it's going through 0, 0. Whereas cosine starts at the maximum value of positive 1. That's going to be also an important fact as we get through some of these graphs. So let's take a look at the equation given there in question number 1. It says y equals 2 sine theta plus 3. What types of transformations are these? Now I'm going to try and move through these notes fairly quickly to keep the video a little bit shorter, but remember that you can always pause or you can rewind if you need to hear something again. In this equation, there are two transformations. The first one is a vertical stretch by a factor of 2. The second one here is a shift up of 3. Both of these impact y values. So what characteristics of the sinusoid will these transformations impact? Take a look at the things that we talked about. Amplitude, sinusoidal axis, period. I also commented on where we sort of start the graph. The ones that are going to be impacted by this, well, the vertical stretch is going to impact the amplitude. So the amplitude is going to be twice as big. The shift up 3, well, it moves everything up 3, but we're going to specifically talk about the center, because if we know where the center is, then we can find everything else. So the shift up moves the sinusoidal axis up 3. And we're going to abbreviate that here, SA. So then how could we use those ideas to graph it? Well, I know now that the amplitude is going to be 2. It's 2 times as big as it was before. The sinusoidal axis is going to be shifted up 3 units. So instead of being at 0, it's going to be at y equals 3. The period of the graph has not been impacted by these things, so it's still 360 degrees. What I'm going to do on the graph is I'm going to put in a dotted line at 3. This is my center. This is the new sinusoidal axis. With an amplitude of 2 now, I know that the graph is going to rotate 2 above and 2 below that sinusoidal axis. So there's going to be a maximum value at 5, and there's going to be a minimum value at 1. And the whole sinusoidal graph is going to rotate back and forth between those minimums and maximums. A period is 360, and if you remember, we had a critical value. We'll be using that word more often too. Every 90 degrees. All right, so how do I start this? This is where we're going to go back and look at, this is a sine, and a sine wave starts on the sinusoidal axis and then goes to the maximum. So it's going to start here, and then at 90 degrees, it's at the maximum, and then it follows that pattern. And then this would be one period of the graph of that equation. All right, take a look at the next page. We're just going to go through and make predictions of how the graphs will change from the original parent function. So here we have another sine graph. The amplitude is affected by the vertical stretch, so that's now going to be 2. The sinusoidal axis is impacted by a shift, so this is now at y equals 5. The period of the graph, oops, forgot the I, is still the same, 360 or 2 pi. And it will be clear when we're graphing in your homework which of those you're going to use, degrees or radians. All right, well, how about this one? This one, the amplitude, there is no vertical stretch, so the amplitude is still 1. The sinusoidal axis is now, we're shifting down 7, so it's at y equals -7. Now the period of the graph, this time this is different. This equation right here has a horizontal shrink by a factor of 2. So it's sort of squishing the sinusoid in closer. So the period of the graph is 360 divided by 2. It's half as big. Or it's 2 pi divided by 2. So then let's look at C. The amplitude, we have a vertical stretch by a factor of 6. The amplitude is going to be 6. The sinusoidal axis, there's no shift up or down, so that's still at 0. The period of the graph now, this is a stretch. So I'm either doing 4 times 360, which is 1440, or 4 times 2 pi, which is 8 pi. But then there's another thing in here, the reflection. So when you're thinking about the reflection, you would stretch and then reflect. This is a reflection over the x-axis. Normally a sine wave would look like this, right? So imagine reflecting that over the x-axis. What's it going to look like? Well, instead of going up to the maximum, it's going to go down to the minimum. And that black graph is what it's going to look like. We'll graph one of those in number 3, so you'll see that. All right, part D, the amplitude, it's got a vertical shrink by a factor of 3, so that's going to be the amplitude. The sinusoidal axis is going to be at y equals 5. The period of the graph, this is a shrink by a factor of 6. So either 360 over 6 or 2 pi over 6 is the period of the graph. All right, let's put this together and make a picture. This says in here, whoops, I got a little leftover ink, to do from 0 to 720. All right, so here's the equation. What is the amplitude? Well, the amplitude is going to be 3 because there's a vertical stretch by a factor of 3. Everything has been shifted down 2, so the sinusoidal axis is y equals -2. The period of the graph, there's no horizontal stretch or shrink in there, so we're going to go with 360. All right, I am going to label out critical values on the x-axis all the way up to 720. So this will be 450, 540, 630, and 720. All right, the new sinusoidal axis is at -2. So we will roughly put in where -2 is. The amplitude is 3, so the highest point is going to be at +1. The lowest point is going to be at -5. And I'm just going to put some dotted lines in for those 2 places. Okay, this is a sine graph, which starts on the sinusoidal axis, but it's a reflection. So just like I was saying before, instead of going to the maximum, I'm actually going to go down to the minimum at the next critical value. And then follow the pattern through. And 720 should be 2 periods of the graph. There's 1, and then there's 2. All right, question number 4. Like I said, I know I'm going fast, so feel free to pause and slow down and re-listen to it if you need to. All right, in this question, this is a cosine. This will be a new one, but the transformations are all the same. So the amplitude is going to be 2 because of that vertical stretch. The sinusoidal axis is moved up to 1. The period of the graph has not changed. Take note that we're in radians now. So I'm going to label out critical values, pi, 3 pi over 2, 2 pi. And this says to graph from -2 pi to 2 pi. So I'm going to put some critical values back this way too. Whoops, forgot my negative. -3 pi over 2, -2 pi. The new sinusoidal axis is at 1, so this will be the center of the graph. The amplitude is 2, so that means the maximum will be 3. And the minimum is going to be -1. Gets a little tight in there with the labels and the dotted lines. All right, so this is a cosine. A cosine graph does not start on the sinusoidal axis. A cosine graph starts at the maximum. So the first point that you're going to put in the pattern is up here. And then we'll go to the axis, and then the minimum point, and then continue on. And then we're going to work it backwards too. It just continually goes through that pattern. And that is 2 cycles of that cosine graph. All right, so let's write down exactly what all of these parts of the equation are. When you have an equation written in this form, and take note of this, we'll do this in a second. The A is the vertical stretch or shrink. And this tells you what the amplitude is. So the amplitude is the absolute value of that number. The other vertical transformation is the K, the vertical shift up or down. Vertical shift. This tells you that the sinusoidal axis is at y = k. All right, now let's look at the horizontal ones. The horizontal transformations, B is the horizontal stretch or shrink, and that impacts the period of the graph. So the period of the graph is always 360 divided by b, or if you're in radians, it's 2 pi divided by b. Now the h, we haven't graphed one yet with the h in it, but the h, which is a horizontal shift, is also called the phase shift. And the phase shift tells you where to start one cycle of the graph. So start one period of the graph where x is equal to h. All right, let's go through these here at the bottom. Notice that these equations are not written in exactly the same form. So before you answer these questions, what I'm going to do is this. I'm going to factor out the b. Okay? So then the information that I have, the amplitude is 5. The sinusoidal axis is y = 4. The period of the graph in degrees is 360 divided by 2, so that's 180 degrees. And the phase shift is right 15 degrees. So that's where we would start one period of the graph. Here, if we're doing this one in radians, same thing. I need to factor this out before I answer these questions. So that's what that will look like. The amplitude is 3. The sinusoidal axis is y = -2. The period of the graph, 2 pi divided by 2. And then the phase shift is right pi over 2. All right, let's take a look at one of these graphs again, now that we have all that information down. If you look at this, there's no b to factor out, so we're good. The amplitude is 4. The sinusoidal axis is just at 0, no shift up or down. Period of the graph is still, oh, it says radians, so this is 2 pi. The phase shift now is right pi over 2. And so now I've added a few things here. The starting critical point and the ending critical point. The starting critical point is just the phase shift, positive pi over 2. The ending critical point is going to be where it starts plus the period of the graph. So pi over 2 plus 4 pi over 2. It's going to end at 5 pi over 2. So how do I graph all of that? Well, it looks like I just have an x-axis there. So the y = 0 is the sinusoidal axis, so the maximum is going to be 4. The minimum is going to be -4. The phase shift is where I start. So I'm going to start it at pi over 2 this time. And I'm going to count out critical values every pi over 2 until I get to the ending, which now is at 5 pi over 2. This is a sine graph, so I'm going to start on the axis, go up to the maximum, back to the axis, minimum, axis. Now that right there is only one period of the graph. So actually, my ending, because it said to graph 2 periods, is going to be at 9 pi over 2. So if I keep doing critical values, this will be 3 pi, 7 pi over 2, 4 pi, and then 9 pi over 2. All right, I've got the pattern going. At 3 pi, it'll be up high. There we go. Now that is 2 periods of the graph. All right, next question, which I think has gotten a little sliced between pages here. Okay, here we go. Amplitude of this graph is just 1. There's been no stretch or shrink. The sinusoidal axis is at y equals -2. The period of the graph, well, b is just 1 here, so the period of the graph is still just 2 pi. The phase shift is right pi, so that means that's where it's going to start. So the starting critical value is at pi. Let me draw this here. We're going to need a little bit more below than usual because the sinusoidal axis is at -2. The amplitude is 1, so the highest point is -1. The lowest point is -3. All right. The ending critical point. Well, if the period of the graph is 2 pi, and I have to do 2 periods of the graph, the ending is going to be at 5 pi. So I'm starting it here at 1 pi. Next critical value is 3 pi over 2. Then 2 pi. 5 pi over 2. 3 pi. 7 pi over 2. 4 pi. 9 pi over 2. 5 pi. All right. This is a sine graph, so I'm going to go back to this and go, okay, oh, my apologies, it's cosine. Cosine, but reflected. Cosine would normally start at the maximum point, but a reflection means it's starting at the minimum point. So we're going to go through the pattern, starting at the minimum. At every critical value, it's hitting either the axis, a minimum, or a maximum. That's 2 periods of that graph. All right, last one that we have to get through. I know this is getting long. This is an important one because this is the first one that has a horizontal stretch or shrink, which impacts these critical points. All right, amplitude is 3. Sinusoidal axis is at -1. The period of the graph, 2 pi divided by 4. The whole graph happens in a span of pi over 2 radians. The phase shift, there is none, so we're going to be starting at 0. So the starting critical point is 0. Where is the ending critical point? The ending critical point is pi over 2. So this time, let me get this in here. We're at -1, we're going to be at +2, and we're going to be at -4. So you have a period in here of pi over 2 that has to be split evenly into 4 spaced out critical values. So there is going to be a critical value what you need to do is take the period of your graph divided by 4. There needs to be a critical value every pi over 8. So we'll start here. 0 is the first critical value. Then there's a critical value at pi over 8. Then there's another critical value at 2 pi over 8. Then there's another critical value at 3 pi over 8. And then there's another critical value at 4 pi over 8. Look at that, 0 to pi over 2, well, that's 1 period of the graph. If we have to do 2 periods of the graph, we're just going to keep going. So 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, and 8 pi over 8. So that should make sense if a period of the graph is pi over 2, that 2 periods would go from 0 to pi. Right, let me get all my lines in here. Once you have all the numbers in the graph, you go back and look. It's a cosine that I'm graphing, and it's not reflected. That means it starts at the top. And then you're going to go through the pattern of graphing here, 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 and so on. And you can see there's one period of the cosine graph, and then there's the next one. And the whole thing happens between 0 and pi. Okay, your homework tonight is homework A. Your packet is split up. So the first half of it is the note sheets and the back half of it is the homework. I know there's no page numbers on there, but you're going to have to flip through the back and find homework A, and that will be due tomorrow. And we will go back through all of this that you've heard in the video again tomorrow in class. Hope you enjoy the rest of your day.